talked about the data structure layer, as I showed you before, and the data content layer. And now we will move to the question how to, we talked about information categories, data fields, the description of the record in your database about your your subject of documentation. And now we move to the question, how are these data fields populated, which are the data values, the data entries, and the question how to relate different entries from different systems. How can we control the entries? And at this point in the library world, there is much more experience. It's much more usual to use controlled vocabularies for your documentation. In the museum field, there are a few vocabularies such as the AAT that are big ones, but in fact, in many databases, the data values are very badly controlled. But at least, or anyway, in the museum or in any institution, you may have your own vocabulary, you may have your own necessities on the level of detail, for example. And at the moment when you are publishing your collection information, you also publish these vocabularies that you use. It might even not be a fixed vocabulary, but just the index of one data field. It can also be seen as a list, just a list of controlled entries. And I want just to show you in the first step how these 2 points relate. We have now talked about this part, how to deliver information to repositories, to centralized repositories, but also to decentralized repositories such as the semantic web. And now we want to know how can we make use of the terminology that we use to get better research, retrieval results, and to relate the different information, make connections, linking the data that we have published. And this is the point where SKOS, the Simple Knowledge Organization System, is used for. And at the beginning, I will give a very short introduction to RDF, as this is the background for the SKOS data model. And these few slides that I show you here, they are completely, I haven't made them myself, they are completely taken from a very good introduction, as I find, which you can find on SlideShare, on a portal where presentations are shared. It is called the 30-minute guide to RDF and linked data, and you will have also the link afterwards in the presentation. So RDF, first of all, it's as SKOS. SKOS is a quite new recommendation of the W3C, a quite new work of the World Wide Web Consortium. RDF is already a well-established work within W3C, and it's a recommendation. It's published as recommendation. So in essential, RDF is in essence a simple, really just a simple data model. It is about writing down relations between things. We have seen before relations, and RDF now provides a general mechanism how to write down these relations. It can be seen, it is the data format for linked data, as it allows to make connections between different data records, data sets. For further information, see the W3C website on RDF. What is RDF for? The web, so far, it has been developing over the years, but at the beginning and still until now, I would say it is mainly a global universal information space for documents. You publish HTML, maybe also JPEG files or other files, but you publish documents, and generally you have metadata about these documents, like a Dublin Core record. Now the question is, can we do the same for data? Make the web into one big database. This is the focus of RDF. RDF is, can be seen as the data format for that database. It allows for machine processing of data sets. Until now, publishing documents and linking documents is mainly made by hand, and the RDF data model now allows to automate these mechanisms. What is quite well known, imagine a typical database table. Here you have the rows representing things. Here, for example, an entry about a book with the title JavaScript from an author, David Flanagan. And the columns, the columns represent the property. Here is set, you have a book and its title. Title is the property. DC Dublin Core title is an entry like practical RDF or JavaScript. The intersections between the rows and the columns represent the properties of the things. So here you can say this book that is identified by an ISBN number, and it has a title and it has an author. We can draw a picture of that information. The book has a title. Very easy. And now we can generalize this picture, and this is really the essence of RDF. You will have seen already many of these RDF triples pictures. It's like a sentence in natural language. You have a subject, you have a predicate, and you have an object. You have the subject of your information unit, then you say, what do I tell about this entity, and then you have a value. This is, the most basic essence of the RDF triples. We can now select multiple properties and attach them to this one entity, the book, title, ISBN, author. And when we just have a look here, here we have an entry to a publisher ID. And this is in a relational database usually connected to another entry, to another table where you have for this publisher ID the information, what is the name of the publisher, where is he located, and so on. So you can connect this information and represent it as a graph in this way. The book as an entity is related to another entity, the publisher, and the property between them is here defined as publisher. Now, using the web's infrastructure for these, for these information units, for a web scale database, we need to be able to identify things globally. So it must be available globally, all over the world, and it must be identified uniquely, because the identifier in your home database, it's just unique in your home environment. So the second essential point is to use URIs, and especially URLs that are nothing else than HTTP URIs that are able to point to a representation via the HTTP protocol. These URIs already provide these capabilities. And this is really the key to linked data. Express your information in RDF triple and assign them a URI. And then this information can be processed automatically by semantic web applications. Yeah, I think simple rules. The URI identifies this thing you are describing. And I really want to stress this point because as we were talking before, be aware what is the subject of your documentation. Here the same applies. Be aware and do think carefully about what is this thing, the thing that you are identifying with an URI. Now, if two people create data using the same URI, they are describing the same thing, we assume. And this makes it easy to merge data from different sources together, and RDF provides the mechanism for that. RDF data can use URIs from many different websites. It's just to be available on the web. I already mentioned that you have several common patterns for URIs, but I think the really important point is that you have to distinguish URIs for the different resources you are dealing with. On the web you have information resources, but you have also information about non-information resources, such as a city, New York City, or such as a museum object, which is a real-world object and it's not accessible via the web. It's just information about this object that is accessible via the web. And this is a very important point that you distinguish also the identifiers for these different entities. There are different patterns, that doesn't matter at all, but just be sure that you don't mix up and apply the same URI to the real world thing and a web resource, for example. That's a very important point. Yeah, this is now an example, just how to merge information. You can now, you may have on one side just information about a person that is called Shakespeare, and you know this person has wrote several books, and you have the URIs of these books. And at another place, you have more detailed information about these books. For example, you know that a person named Shakespeare wrote a book identified by a specific URI, and about this URI you can find at another place the information that it was written in 1605 and that it is that the book is titled King Lear. So this is the way how data is interconnected. This is very boring, I think. And it's the only slide showing RDF XML. As I mentioned before, the technical or generating the RDF XML at the end is quite easy if you know the semantic content and if you have a good mechanism for assigning identifiers. So now coming finally to SKOS, the Simple Knowledge Organization System. It is an RDF application. It is as well developed within W3C, within a working group, and the current status, it's quite new. It has become a W3C recommendation by August of last year. It provides a model for expressing the basic structure and content of concept schemes, and this is a general expression for several kinds of controlled vocabularies, such as thesauri, classification schemes, subject heading lists, taxonomies, folksonomies, and other similar types. I want to point you to one thing. Note already here that authority files are not specifically mentioned in the scope of SKOS, and I will come back later to this point. Because authority files are slightly a bit more difficult to handle. So the main objective of SKOS is to enable easy publication of controlled structured vocabularies, and it's important to see of existing controlled structured vocabularies. As the standards that I presented before as well are just for publishing data that is already there in your database, and it doesn't you don't have to change your own database structure to publish your data in a standardized way. It might be recommended to adjust some semantics, but it's important to understand that all these standards are not, they do not try to cover the whole world of museum or any other documentation, and also not the whole world of knowledge organization systems and how to build up a thesaurus. It's specific, the specific focus of SKOS is on linking and retrieving data and concepts. It is not so much on display and navigation within one concept scheme. And this is important. It does not itself specify rules on how to create concept schemes. So we assume we have a concept scheme, such as a thesaurus or a classification scheme, and we want to publish it on the web. So it's really easy publication for the semantic web. Yeah, I wrote that here. Note the difference in scope compared with other KOS standards. KOS stands for Knowledge Organization System, such as ISO standards for monolingual or multilingual thesauri. They have a much wider or more detailed scope, or describe much more detailed how to build up a KOS. So this is from the very definition in the SKOS reference. Using SKOS, concepts are units of thought, can be identified using your eyes, labeled with lexical strings in one or more natural languages. They can be assigned notations, They can be documented with various types of note, linked to other concepts, and organized into informal hierarchies and association networks. So these are the semantic relationships. They can aggregate it into concept schemes. Usually they already come as concept scheme, and you just generate this SKOS representation for your concept scheme and all the concepts in the scheme. You can group it into labeled and ordered collections and map concepts in other schemes. This is a very important point, as I show you later on. I have taken a record of the art and architecture thesaurus as example. It's the paper money concept within the AAT. I've been working on this together with a colleague from the DigiCult project in Germany. So what you will see now is a cooperation of both of us. So first step, identifying the basic entity, that is the SKOS concept. What is a concept? As I mentioned before, it's a unit of thought that is ideas, meanings, or categories of objects and events. That is important here to know. To note, we are talking about conceptual ideas and categories of objects. So we are not talking about one specific instantiation of a concept. For example, the paper money is a concept, and if I have a 20 shekel bill, this is an instantiation of the paper money. We have to do two steps for identification. First, we have to create a URI to uniquely identify the concept. And second, we have to assert in RDF that this resource we are now talking about is a SKOS concept. That looks like this now. This is the entry of the AAT record. This is the description in RDF. And this relates to some information in the original AAT structure. So you have to decide how you create your URI. Usually you will have an approach like this. And you may be more or less common with namespaces in the web. You can just assign a prefix to this part of the URI and say that AAT is equivalent to this identifier, and then you have a shorter representation, a concept with an identifier, or an entity with an identifier is of type concept. For this concept now is described basically in two ways, or in three better. First, the lexical labeling. You have different labels for this concept. These are expressions, natural language expressions that are used to refer to a concept, just to call it in natural language. Here we distinguish, or most of the knowledge organization systems distinguish, preferred lexical labels. For example, here we have paper money. And note, even though in SKOS it's formally not enforced, but it's recommended that no two concepts in the same concept scheme should have the same preferred label for any given language. You have a pref label, the preferred label for this concept, and you distinguish different languages. but usually in KOS it's called homonyms. You should not have the same label, the same preferred label for different concepts. And here I showed the graph. This is represents the concept, and then you have various properties, and this will be growing now with other properties that we are approaching now. You have alternative lexical labels. These include synonyms, also near synonyms, abbreviations, and acronyms. So in the AAT, for this concept, you have many different alternative labels. And this looks in RDF like this, that you just assign the property pref label and alt label to these different strings. You can also have hidden labels, which are normally used for, especially for misspelled variants. You want to be a label searchable, but it should not be visible on the net. This is hidden labels are not part of the AAT, so I just invented this example. You may find paper money without the blank in the middle, and you want to this to be found as well. Another kind of labeling is assigning annotations, assigning notations. So this is especially used in classification schemes, and notations are typically composed of digits and punctuation signs and other characters, and the main point is that they are independent of natural language context. For example, in the icon class system, you have a combination of digits and characters to identify a concept that then has pref labels in different languages. Here, villages Vian, and the form of the notation is a specific data type you can assign. Note that this is the way in SKOS to represent notations. Normally, you should use this property, SKOS notation. But alternatively, you can also assign a pref label without language tag. And this means that this pref label refers to a non-natural, an artificial language, such as the encoding scheme for the notation. Then you can have human-readable documentation of the concept. This is also identifying, describing your concept, and you can have different kinds of documentation. The AAT deals only with scope notes, but for each concept you have a scope note, which describes the scope of the concept. Then you may have definitions, examples, and history notes. This is then a question on how to, if you want to publish your data, you have to do a mapping of your, the structure of your vocabulary to SKOS, and many vocabularies that I know, at least used in the museum world, haven't any documentation at all. Often we just have labels, and this is the next point, the semantic relationships between the concepts, the broader, narrow relationship and the related relationship. Broader, narrow here in SKOS reads as has broader concept. So if we look at the paper money example. Here we have the concept with the pref label paper money, and this concept has a broader concept that is called, that has a pref label money, and this one, so these properties are each other's inverse. If this concept has a broader, so this one has a narrower linking back to the same concept. But note that these properties are not defined as generally transitive. In very well-defined knowledge organization systems, mostly thesauri, this will usually apply, that if you have this concept has a broader here, and this may have a next broader concept, so you can also conclude that this concept has this as broader one. But the different vocabularies SKOS is dealing with, the practice has shown that there are somehow more dirty vocabularies, so that there are broader, narrower relationships between entities that do not correspond to each other, so that this conclusion may not be right. So these properties are not defined as generally transitive. This is one important point, by the way, that as SKOS is also, it's like an ontology for controlled vocabulary. It tries to be very, in an ontology, you should be semantically very correct, and you should. It should not be possible to make conclusions that end up in semantic nonsense at the end. Because at the moment where the data is processed automatically and no person looks on it, you may get very fuzzy conclusions and interpretations. The next relation, or one separate property, is the related relation, which just asserts an associative relationship between two concepts. And here I've just taken an example of the SKOS reference because I hadn't the time to search for one in the AAT. If you have a concept birds, then you may assign a relationship to another concept with a pref label ornithology. There is no broader narrow relationship between these two concepts, but they are just ornithology is about birds. Yeah.
You mentioned ontologies. In SKOS, there's only broad and narrow and related concepts, or, for example, in the example you bring, ornithology is the study of birds. So the relationship would be between, it's not just a plain related relationship, but it would be ornithology, study of, that is the relationship,
yes.
And birds.
Yes.
So can you put that into SKOS, more specific relationships, or that it's just related like in a regular thesaurus?
You can, well,
is this predefined?
No, it's not. No, it's not predefined.
If I'm building in SKOS, can I define these?
Yes, you can define refinements.
Right.
Yeah, and usually maybe you will import these properties from another ontology. If you have described in another ontology this relationship that ornithology is the study about this other concept, you may just import that into your representation.
You say that SKOS there's not really any rules in a certain sense, so that when you're saying I can import these relationships with another ontology, if I use several ontologies, for each ontology, study of, well, for instance of, there's all kinds, and they may not always match. So the question is there anything in place that SKOS will be able to, that I can normalize these relationships so that they will be across the board and consistent? I hope you understand what I'm trying to say.
More or less, I think. Yeah.
Am I right that you can simply define what ontology you're taking from, or if it's from double core or more?
Yeah.
Oh, so they don't have to be consistent, they're just defined.
Yeah.
Oh, okay.
Yes. Mm-hmm. Yeah, that's the point. And on SKOS itself really just provides these basic structures. You can then define refinements, but relationships like a study of this would not be a refinement within SKOS, but you would import it from another ontology. And just assign in the RDF document that you use another namespace, and then you assign this property. Mm-hmm. There is a refinement that is called broader transitive and narrower transitive. So you can assign these, these are the properties that are defined as transitive between concepts. Mm-hmm. Okay. The next point is the aggregation in concept schemes. As I mentioned, usually you come the other way around. You have a concept scheme and you want to publish it with SKOS. So the basic structure of SKOS is the concept, and you can use one concept as a standalone entity. And you can also import, for example, you have a concept scheme and you can import a concept from another concept scheme within SKOS. The usual approach and knowledge organization system is that you build up one carefully compiled system of concepts with semantic relationships and labeling and so on. And then you may publish this entire concept scheme also in SKOS. And especially for the concept schemes, there's just one property that is assigned between concept schemes and concept. That is the has top concept property, which provides you a mechanism to assign an entry point to the vocabulary. But if you want to describe the concept scheme, you have to refer to other ontologies as well as Dublin Core, for example, and say that this concept scheme we are dealing here with has the title Art and Architecture Thesaurus. Yes?
When you use another ontology, will you still be able to interpret it using SKOS, or will you still have the advantage of using SKOS if you bring it from another ontology?
Yes. The point in the whole RDF thing is that you deal with entities and relationships between entities. Though here, your entity is the AAT. It's you assign it an RDF type, and the RDF type is SKOS concept scheme. But you can assign it as well properties of any other ontology like Dublin Core. But that doesn't. You can just skip this, and you still, if you only use the SKOS or you only need the SKOS relationships, you just use them, and the others don't affect your the semantic correctness. Yeah. The next point, interesting to see also, is you can group into collections concepts, and the AAT, for example, is structured in 4 types. The AAT deals with facets, with hierarchy names, with guide term, and with concepts. These are the 4 types of entities that are defined in the AAT. And here you can already see 3 of them map to SKOS collection. And only the AAT concept maps directly to SKOS concept. So this shows already, or the other way around, the AAT deals a lot with display and navigation through the hierarchy. So you can group the concepts into facets and then guide terms that are node labels, so that you. I'll show you an example. This is better to explain, I think. Or just. Maybe I just go back to the AAT record quickly to show you. So, here you can see the hierarchical position, and you can see entries in these brackets. These are guide terms in the AAT. So they are not concepts on its own right, but they just serve for structuring or for grouping the concept scheme. And the main point in SKOS now is that all these kinds of, this is the right one? Yeah. Such structures like node labels do not represent a label for a concept in its own right. So a specific entity is to be introduced, and this is in SKOS, the SKOS collection with the property SKOS member. But here you can see you can just relate from this concept paper money to a collection level, which is money by material. But there is no relationship between the broader concept and the collection itself, which is the case in the original AAT. So this is just an example that it's like a generalization. You don't carry the whole information which is stored in the AAT to the SKOS record set. There is a loss of information if you publish it in SKOS. But as it's focused just for retrieving and linking data, it's enough. So that's just what you want at the moment. Okay, and then the last point I want to focus here within SKOS is mapping concept schemes. You have several properties that allow for statements that two concepts from different concept schemes have comparable meanings. This is, this is one of the key advantages we hope that we get from making knowledge organization systems available on the semantic web using SKOS. Because this is useful for retrieving data repositories and union catalogs as well. If you integrate data, as we do it in our online database, for example, from different sources, and these different sources use multiple thesauri, different knowledge organization systems, which are conceptually overlapping, you get better retrieval results if you map the concepts between two concept schemes.
That mapping is done by hand, or is that done by machine?
It's mainly by hand. It has to be done mainly by hand, because yeah, you may perhaps search for same pref labels in different concept schemes, and then assume that if you have the same preferred label, it may be the same meaning, but you can't be sure. So this is really something, yeah, it has to be done by hand. And in the within our working group, or the working context in the German Museum Association, we try to do that now as far as possible, but it's really, yeah, it's hard work. So the idea is you have one concept in AAT with a pref label paper money. You have one concept in a German classification scheme, which is called Hessische Systematik. It has a pref label Papiergeld, that is the equivalent for paper money. You have another authority file, which is the Schlagwort-Normdatei, that is the like the subject heading list used in or provided by the German National Library and used within German libraries, that has also a concept called Papiergeld. These three concepts from different concept schemes, yeah, they as described in SKOS, they are exact matches. They really define or they really mean the same concept. But you have different identifiers for them. In one concept scheme, you have one identifier, and here the next, and here the next. And if you deliver that information to a larger database, there will be no connection between them. So I think it's worthwhile to do this work, and as we are working on several vocabularies with several institutions together, we now try to integrate the mapping to the German, the main German authorities during working on the vocabularies themselves. But this is a long way we have. Yeah.
I don't want to dissuade you from attempting this, but on the other hand, if just from previous work, for example, the publication of the religious thesauri by the Getty, they did a multilingual project that Martha Baca was involved with. So one of the big shocks for her was after the Italian delegation, Canadian, French, and Americans sat around the table with words that they thought they had all mapped, and they put on the table a picture of a choir stall or whatever. They all said, "Oh, is that what you meant?" So when visuals might be very important for the mapping. I mean, if you all think you're talking about a stool, but somebody comes with a picture of a chair to the table, it's important to understand that culturally the terms are not always representing the same object.
Yeah, that's a very important point, and you know that we are actually starting with and we don't even call it AAT translation work, but we call it an AAT equivalence work to German, because you can't translate vocabulary. You just can find equivalence in other languages, and in other languages also another cultural context. And it's very, very difficult, yes. But, well, we have two choices. Or we do nothing, or we try to, yeah. We try to get forward in some small steps, but I think this is a very important point to keep in mind. You have to be very careful, because otherwise you will get semantic nonsense often. and this is not what we want as well. Okay. Nevertheless, well, this is the thing with the whole semantic web. We are not sure if it will succeed, or if there will be. Well, there are a lot of risks also, but I think it's worthwhile as far as we integrate data, try to do this mapping work as well. Yes.
Could possibly work into it some kind of an interactive, gradually self-correcting scheme like in Wikipedia kind of concept in which users would correct these relationships eventually.
Yes, yes, sure. There are approaches, and for example, from the museum world, at the moment we have one big project in the United States. Also, the Steve Museum Project is a project that has collected social tagging for museum collections for the last 4 years, and now they are starting to try to relate these social tags that were provided by users in the social web to link them to controlled vocabularies like AAT and to develop mechanisms on how to correct or how to get forward in this mapping together. But it's So there are a few more features, advanced features in SKOS. There are also quite a few features that are explicitly, that SKOS explicitly not deals with. For example, coordination of concepts, which is a very common thing in thesaurus work. SKOS doesn't deal with that at all. It really focuses on the publication, on the easy publication way. One advanced feature that was added now with the last recommendation is the SKOS extension for labels, because there was a quite strong need or request for the possibility to link also labels, not only concepts. SKOS basically only deals with concepts and does not allow for relationships between the labels for the concepts. This extension provides a mechanism for identifying, describing, and linking the lexical entities, the labels. If you're interested in that, I don't want to go in detail here now. I think in the first step, it's just important to map your data to the basic structure, and moving forward, maybe you will need some more extensions as well. But for starting, I think the basic structures I have presented. Now I want to focus on one specific point, because that has been a extensive discussion thread in the SKOS mailing list in the last few weeks. About this point, as I mentioned at the beginning, in the listing of for what SKOS applies, authority files are not mentioned. The question is why? Attention. The point is that authority files deal only with labeling properties, and usually not with semantic relationships between the described entities. Even though we have many vocabularies that, for example, that start as an authority file to control the names for entities, and then introduce also semantic relationships. You have many mixtures of authority files and thesauri, for example. But from a theoretical point of view, authority files deal only with labeling of entities and not with semantic relationships, whereas thesauri deal with, especially with the semantic relationships. So the second point is you have to look what kind of entities does your authority file deal with, because often authority files deal with particulars, with individuals, and SKOS, as we know, the basic structure is a concept and not an instantiation of the concept. And authority files, like the United List of Artist Names, for example, or the whole VIAF project, the virtual authority file that is linking the different authority files on persons in lots of countries. They deal with particulars, with individuals. And the point is that you run into a problem if you use the SKOS vocabulary for such entities, because not the whole SKOS vocabulary then applies for your particular entity. For example, there are no broader or narrow relationships between persons. So you may use SKOS to assign the different names for a person. But if you use the SKOS ontology for doing this, at least you have the possibility also to assign these semantic relationships, which is semantic nonsense. So here you really have to carefully analyze which is the appropriate vocabulary. For example, for real persons, there is another ontology that applies well. That is the FOV ontology, friends of a friend. So for publishing, for example, EULAN, at least I would say that that SKOS is not the most appropriate vocabulary. You use the FOV ontology, for example, and you import just the SKOS pref label property to assign a preferred name, for example. This is possible. But don't mix them up.
I'm not 100% clear on the difference between the concept and the preferred label. Because, for example, in LCSH, the concept would already be the preferred label. In paper money, for example, paper money is a concept. What would be the preferred label?
Well, that's the basic.
Steps have to be combined into one.
But can I answer? A concept is something artificial. It could be in a single language. You can decide that all your concepts are in English, but your preferred labels can be multilingual. And that's where the strength lies in SKOS, because you're mapping in a multilingual plane.
You can see a concept. You can see concepts in the UNESCO thesaurus in their top charts. You would see their concept, and then you would see the whole development.
So it's just random what language the concept is in.
Right.
Whatever you decide.
Yeah, but it's a basic point to make this distinction, as you explained. Often you will feel that it is the same, the label and the concept, but
I think it's especially useful for multilingual,
Yeah,
which is why,
that's right.
why you're really doing
yeah,
it here.
yeah, that's
If you're
the point.
only in America and you've got the AAT in front of you, you don't need SKOS.
Mm-hmm.
The point is, if you want to map it to multiple multilingual thesauri, this is where it's strength lies.
So its main use is for multilingual mapping, not multi-concept, as schema mapping.
It can be used in both ways. But
Okay, so Moving forward to SKOS applications, here I just want to point you to 2 websites, because you can look there. The SKOS homepage, there are several applications mentioned. DOF has also put together some SKOS resources on the Minerva website here, so there you will find a lot of examples. I now just want to present you what we are doing in Germany with SKOS and what are our applications. So I will focus on this. Sorry? Okay. So in Germany, about 2.5, 3 years ago, we started an initiative within the German Museum Association that is to build up a platform, an online platform for museum vocabularies, because we realized there are many different vocabularies in use. There are many different versions of the same vocabularies in use at different places, as they are mostly distributed just by copying the digital file on a USB stick and giving it to your colleague. And there is no main or no central point where to get information and also get vocabularies. So we've built up a platform called museumsvokabular.de, where several partners, you can see here all the institutions that are involved with, under Creative Commons license, a platform where we provide information about vocabularies and we provide also the vocabularies themselves. For that, we have built up a web service called Museum Voc. And first, I just want to focus on the format that we use here. Our format, we call it Museum Voc. It's a format for describing controlled vocabularies. It is based on SKOS, but as I mentioned, SKOS really focuses on just on the very basic structures of vocabularies. And since we are also focusing on developing vocabularies, on really working them, we need some more features. So we defined a format, Museum Voc, that is in the basic structure SKOS, but it imports further properties. As it is with standards, they are still under development. They are always under development. We have published one version in 2007. Since we have now started, especially with the AAT work, we realized that we need quite a few more things, or that we have to adjust quite a lot of details. I won't go through this now, but just to emphasize that if you do more than just publishing an already existing vocabulary, you will need some more features, and you will not be happy with SKOS only. So this is a framework that we're working with several partners. It includes also software development, that is currently that will be available as open source as well. But here I now will focus just on the publication of the vocabularies. Here you see this is the website where we publish, where we give information about different vocabularies, and we publish them just as a PDF file so that you can really read the vocabulary, and we publish it in 2 XML variants. The one is the museum VOC format, which is a proprietary format within our context, and the XML download includes also SKOS RDF XML, so that you can reach these concepts. I have to say that for the moment there is not the whole database. There is no online retrieval in the database. I hope that we are getting out with this with that this year also. These are now these are so far the XML files that you can get, but you can't retrieve online the vocabularies. You had a question? No. Okay, I thought. So there are several vocabularies, and as I mentioned before, we try to do this mapping work. Well, we see how far we will go. 2 points about web services as a whole, because the word web service is often used also just for publication of files online, but in the narrow sense, I want to focus on this. A web service is a machine-to-machine interaction. So you have a software, you have a client and a server, and you don't have to go through a browser, through a human interface, but you can just retrieve a database by a software client. We have defined a SOAP web service. SOAP is one protocol for exchanging XML-based messages, and yeah, it's commonly used for web services, but there are also other kinds of web services, as with the REST protocol, but yeah, technical stuff. The main point is we have 3 central functions defined in the Museum VOC web service. One function is just search a concept by its ID. So retrieves from a given list of IDs just the pertaining concepts. The second function is search concepts by term, so that you retrieve on the label level from a given list the pertaining concepts, and you may make a difference. You may distinguish between searching for only preferred labels or all labels. These functions have quite a lot of parameters you can refine. And the last, but maybe most important function is the fetch hierarchy function. So for a provided ID, you get back the requested tree of the hierarchy. And you can also define up to which level you want get back, and if you want get up or down in the hierarchy. Yeah, depths of search and direction are parameterized. We have online just a test client for this web service, but the important point is that this web service is already implemented in several museum documentation systems that are in use in Germany. As I mentioned before, we are extending currently the format and also the web service to be interactive. So far it's just readable. You can just get concepts that are already in the database, but we now do extend it so that you can also make suggestions for new concepts, and so that also the proper work on the vocabularies gets implemented into the documentation systems as well. Yeah, it's just an illustration on how does it work, connecting the build index, our online database with AAT, for example. That's not already implemented because we haven't the AAT in German so far. But the main idea is that we publish the information on the collection objects, and we refer. This is the main point here. We refer just to a concept ID, and this ID, this is a URL as it is necessary for web services to identify the concept in a globally unique way. We provide a URL, and this identifier then can be found automatically via the web service in the vocabulary. This can be done with any other controlled vocabulary. For example, there has been a relaunch of the icon class website in November last year, and they are also implementing, they provide already a prototype for an icon class web service, and this for us as our database is indexed with icon class as a whole. That would be a great step forward as we then can search the database also in the 8 different languages that icon class provides. So far we just have the German entries, but if we can use the icon class web service, we can make the database searchable also in the other languages that icon class provides. Okay, and then I might be at the end. I just want to show you one demo application just to see what is the effect. We have put that on the museum's vocabulary website as well. So I hope that this will work now. Just to show you what is the difference if you search in a collection with controlled vocabulary, with a terminology service in the background, and without. So if you, I have entered that before, if you just look for, it's a German, it's a bottle, as you will see, you get back only one item. So this is the collection of a historical museum in Leipzig, and this is indexed with a German, just only available in German, with a vocabulary for Gefäße. What is Gefäß? Anything? Yeah. Okay. So this is one specific kind here. And you get back only one item. But now if you search this same database with a... No, I have to go here, I think. Okay. And now I perform a research in the same in the same data repository, but using the museum web service in the background. So the web service gets the label entry, Flachflasche in this case, asks via web service if there are narrower terms to this concept, and then searches for all the concepts in the data. In the database, and so if you search with a terminology web service in the background, you will get much more entries as they are indexed with narrower concepts.
I'm missing something. You say that this service is located at some central place like your institution?
Yes.
And every time that I do a search in this particular database, it consults your data.
It consults once, and it's not. It's my former institute where I used to work before in Berlin, a research institution. Yeah, but there they provide the web service.
What do they do exactly? The web service, and what is returned to where?
Let me see if I do find the. Oops, sorry. I will go to this slide. So what happens is I have a data repository here, and this is a database of the City Museum of Leipzig. And here I stored the data about the collection, the museum collection. And this museum collection has been documented, has been indexed with a controlled vocabulary, which is not locally available in the museum, but which is available via web service at a central point. So what happens is, you are a local user, you make a request to this data repository after a specific term, Flachflasche in this case. Then this server will perform a request to the web service that is provided by another institution and will ask, does this concept has narrow terms? And which are the identifiers for these narrow terms? And we'll get back an answer with all the narrow, the identifiers for the narrow terms. And then this server will perform a research in this database, not only for the identifier of the term that you have that you have asked for, but also for all identifiers of the narrow concepts.
But then this service has to know the particular concept structure of this repository.
Well, this service provides provides access to a vocabulary that has been used. The point is, this service here has to know, or this service has to refer to the vocabulary that is provided here. If you are in the museum, you can use your own individual data, your individual vocabulary, but as it is usual, yeah, it's very common. Just you don't use you use a controlled vocabulary that is already known. For example, the AAT, or for example, the UNESCO thesaurus, or for example, one vocabulary of which you know that it is provided. It's a German language vocabulary that applies for your application specifically, and you just the point is from here. This is the museum's collection database, and it uses a vocabulary that is published on the web. More or less. Maybe I can try it again afterwards. there was some other question or? And this is what I wanted to present you about SKOS and the application that we are working in Germany with. And now we have the break, right? Thank you.